This month, we are checking in with Max Mankin from the class of 2007, who is the recipient of this year's Young Graduate Award for his innovative work in establishing alternative energy sources. Max is the founder and CTO of Modern Electron, a sustainable energy technology company with the mission of affordably and practically decarbonizing heat and power. Max, we are so excited to honor you as this year's Young Graduate Award winner. And can you start by telling us a little bit about Modern Electron and simply put, or as simply put as possible, what does your company do and how do you do it?
Thanks, Kate. It's really nice to talk to you, and I appreciate the opportunity to share what we're working on. So, Modern Electron is a startup company out in the Seattle area, and we have two solutions that help people increase their energy use efficiency so they can go further with less fuel and ultimately reduce their carbon footprint, in other words, their CO2 emissions, without having to change their infrastructure. So, in a little bit more detail, what we have is really two solutions or two technologies. The first one increases the productivity of natural gas in residential heating. So, for everybody who heats their home with a furnace or a hot water heater, we help you get more energy out of that fuel. So, that not only saves you money, but it also provides resiliency and lowers your household CO2 emissions. And the second technology or solution makes low carbon hydrogen fuel on site for commercial and industrial customers. And this hydrogen can then be used in their processes today to help them lower their CO2 emissions from their industrial processes like making steel or making other materials.
So, Max, what do you have to study? Like after Nobles, what did you study and what did you work on to be able to tackle some of these big problems at such a high level?
So in college, I majored in physical chemistry at the intersection really of chemistry, physics, and material science. And then in grad school, I went and did a PhD also in a similar field. So I kind of straddled chemistry, physics, material science, as well as energy systems. So the superpower that I bring to leading my team is that I'm able to tango through a whole bunch of areas, ranging from mechanical and electrical engineering all the way through the fundamentals of quantum physics with everything in between. And I'm not saying I'm an expert in these fields, I'm certainly not, but I know enough to be dangerous and at least point people in the right direction. I think the other thing that's really important that a lot of technical folks overlook is I spent a lot of time learning business and entrepreneurship fundamentals and learning from a lot of others who have gone down entrepreneurial, in particular, deep tech energy journeys in terms of how to manage a team, how to build a company, how to position a product and pitch it to both investors and potential customers, and how to align people around a common goal. And I think that those are skills that most scientists and engineers don't learn from school. But for anybody going into this field, especially if you're going to be in a startup or a small company, kind of doing it yourself, I'd highly recommend brushing up on some of those things and finding some good mentors.
So it sounds like you kind of have two superpowers. Actually, you have the science background, and then you also have the business and entrepreneurship background. How does sustainability fit into that? When you founded your company, was sustainability always important to you, or was that something that, as you studied the problem, you kind of realized we can do this better?
Sustainability has always been important to me ever since I was in high school. Actually, around that time, that was the early or kind of mid 2000s, and so around that time, people started talking about carbon dioxide emissions causing global warming and climate change in a really serious way. And the sad fact is that the science community has been talking about it since the 1970s, but it kind of started to receive really mainstream attention in the 1990s and 2000s. And so I knew from the very beginning that I wanted to do some sort of science or technical or math field. I didn't quite know what, but the sustainability aspect of it had always been interesting to me. So when I chose a PhD program for grad school, I ended up selecting a program where I could work on sustainability projects and technologies.
On that side of it, for those of us who don't have, as much of a science background, how do typical heating and power sources work through a sustainable lens? And also how does Modern Electron provide more sustainable heating and power sources?
So let me give you an example from the perspective of one of my favorite customers. So imagine you're a company that produces metal, so like steel or copper or something like that. Basically, to produce that metal, you have to create a bunch of heat to process it. And right now, the cheapest, easiest way to produce that heat is by burning a fossil fuel like natural gas or like coal. But that obviously emits, CO2, which contributes directly to climate change and global warming. So one of our solutions really is think of it as a box, and you can envision this box getting set up right next to the natural gas user. So, like, your metal factory, right? They get this box and their normal natural gas goes in, but hydrogen comes out. And so, what this technology really does is it actually strips the carbon out of that natural gas so that when that natural gas is used to provide heat, it no longer emits CO2.
That's really helpful. So, in theory, this technology could apply to, as you said in the beginning, sort of residential homes as well as larger industries. What potential does this have on kind of turning carbonization and decarbonization? Could this be a long-term solution?
It absolutely could. So there are a couple things that get me really excited about this, among many others, but I'll give you the highlights. The first one is that something like 10 to 20% of our worldwide CO2 emissions come from heating. And this comes both from natural gas space heating of buildings. So, how people, for instance, in New England and the Midwest heat their homes in the winter with natural gas furnaces and boilers, all the way through burning natural gas and coal to produce steel, cement, beer. Even beer is heated with natural gas in many cases. All the copper in your electric vehicles and your wind turbines, that's produced from heating. And so, heat is 50% of final energy demand and responsible for something like 20% of CO2 emissions. So this is really an opportunity to deploy a solution like this to actually make a serious dent in worldwide scale CO2 emissions.
Why is it important that Modern Electron's products are affordable?
The energy industry is one of the biggest industries on the planet. And the fact is that what we've seen again and again and again in the history of the energy industry is that for a solution to scale, it has to be affordable. And one of the reasons for that is that most people and most companies won't spend more on the green solution. So, this is something that Bill Gates calls the green premium, which basically refers to the extra cost that you're going to spend to buy the environmentally friendly or sustainable solution relative to the normal one. And a great example is a Tesla, like an electric vehicle. Right now, a Tesla will cost you approximately 2x what the equivalent gasoline car will. And so, most people, we have to remember that Nobles tends to be somewhat of a bubble, and most people aren't going to be able to afford that. And when you look at companies who are actually even bigger CO2 emitters than private individuals and private households, their whole goal is maximize profit and return to shareholders, and that's their incentive, which makes sense, and I have a lot of respect for that. So inherently, anything that costs more is unlikely to be adopted by the majority of people or by companies who do have shareholders or a bottom line to answer to. So an affordable technology is really critical for it to actually gain mass adoption and scale. And without that, it's unlikely that any sustainable technology, no matter how good it is, could ever actually make a serious dent in CO2 emissions or reach the scale where it has a big impact.
So, Max, you talked about at Nobles how you studied science and then went on. Were there any other teachers or any influences at Nobles that kind of set your path early in this direction?
So many. Yeah, so many. Let me highlight three. So one of them was Jen Kraft, Dr. Kraft, to the current students of Nobles listening. She was my chemistry teacher, and when I was there, she had a independent biochemistry research class, and that was my first exposure to kind of the act of doing science myself and trying to answer an unanswered question and pushing the bounds of human knowledge. And I caught the bug, and that really gave me kind of this platform and this like laboratory literally in which to tinker and play. Another one was Nick Nickerson, and what he was my advisor and my math teacher, and he would always encourage me to pursue things that I was both excited about, but that could also frankly pay the bills. He's a super practical guy, which I appreciate, and that were unusual and put different pieces of different fields together. And I think again, going back to what I was talking about earlier, that's kind of a useful skill that I learned. Like, how do you apply that math that I learned in Nick's class to my ceramics class or to my biochemistry class, right? And most people weren't thinking about things like that. But that was a common conversation that he and I had about, hey, take these things you like and apply them in new areas. And then I actually ended up doing exactly that with art. So Nobles had this art requirement, and when I started there, I hated it. I couldn't deal with it, and I was like, I'm not an artistic person. I'm a techie. I like science and rigorous things. And I took ceramics, thinking, okay, I'll just get this over with, and I loved it. And ended up doing like a senior project actually on the chemistry of ceramic glazes, where I actually explored like the real chemistry and physics behind what gives a ceramic glaze color in a particular form, and wrote up a little paper on it. And so John Dorsey was a tremendous influence there because he really helped me nurture some of that kind of cross disciplinary exploration and combination of science and art.
That's fantastic. Three amazing educators. And Nick obviously just retired this year, but the other two are still here. I'd like to end by sort of asking you two questions, one a little bit morbid, maybe, and one more optimistic. But can you share, sort of looking at the bigger picture of climate change and where we are in the year 2022, what are some things that worry you? What's sort of top of mind with problems that you see happening in our world?
Yeah, I think the worry, I'll give two, but I'll try and transform them into opportunities to be a little more uplifting for our poor listeners here. So the first one is that I think there's a bit of extremism in the climate dialogue right now, and that's a little frightening. And one of the things that worries me is that the metric is not reducing CO2 emissions; it's often righteousness. And I think that we see this in the technology landscape. Like if you're not all in on solar and wind, if you're doing anything else, you're considered evil. I don't think that's true. Like a company like us, we're working on decarbonization, and our metric is how much CO2 we avoid emitting into the atmosphere, and we're taking a non-traditional approach to do that. So I think an opportunity for us is generally more dialogue, better alignment around real decarbonization goals and metrics rather than virtue signaling. The other thing that worries me, and again, this goes back to what we talked about, is that right now most green technology, most sustainable solutions and products are significantly more expensive than the not sustainable option. And a really classic example is aviation fuel. So airliners emit a lot of CO2 from burning jet fuel, and the low CO2 jet fuel is something like 5 times the cost of normal jet fuel. So for an airline, that's a really hard pill to swallow. And so I think there are real opportunities for entrepreneurs and companies, as well as nonprofits and academics, to come along and think about, okay, how can we come up with solutions that are just as good or better than what people use today, but also just as affordable.
Yeah, and that would be sort of my last question. And again, to end with an optimistic note, are there sort of new budding technologies outside of what you're working on that you are really excited about, that you see opportunity with, and especially thinking about our audience, including Noble's graduates, but also current students? Where should the you of 20 years ago be really excited about those opportunities?
So, one of the things that I think is exciting in the climate dialogue and community now is that people are finally starting to realize that the electricity grid is not the only thing to solve. And so we're seeing a lot of companies like ours, but also some others, starting to help big industrials and big commercial players decarbonize things like process heating, decarbonizing transportation, in particular long distance transportation like aviation and long haul trucking and marine shipping. I think is a huge opportunity. And we're starting to see companies come into play there.
Well, Max, thank you so much. This was really fantastic. Thanks for sharing all your insights with us.
Yeah, my pleasure. Thanks, Kate. I appreciate the opportunity.